Alright, so last week we got the Fenderino from Arduino co-founder David Cuartielles, and I'm super excited to finally get the chance to solder this together. As you can see, it's an incredibly cool PCB. This is an Arduino shield that mounts on an Arduino Uno or Leonardo or whatever, and turns it into a MIDI controller. So I have here the Arduino Uno that they sent me. I might eventually try and do this with a different type of Arduino simply because there's a little bit of extra work that you need to do if you want to use it as a keyboard input or a MIDI input with the Arduino Uno, which if you use some other types of Arduino such as the Leonardo or even the TNC, if you can adapt the shape of it, then you don't need to do that extra step. And so it involves an AVR programmer, and I've never done that before. And I would love to try it, but we don't have one in the office. So, what we do have is this rockin' Fenderino shield, and there's a Hackster page for it. You can already search. There's nothing there yet, but we're going to put this tutorial up soon. In the meantime, we have these components to put on. Woo. Besides this sweet pick that came with it, I've never seen a PCB pick before, but it's got, Abierto.cc and David Cuartielles, Instronics.com. I can't pronounce things. Yeah, we're gonna get started putting on all these buttons and potentiometers and a piezo speaker and this cool little LED array that's kind of crazy. You don't usually see those. It's got 4 LEDs in it, and you just got to make sure that you orient it correctly. Yeah, so obviously the headers as well that plug into the Arduino. So let's get started. I'm actually following a guide that is linked from the Abierto.cc blog. It's in Spanish. We can understand that, it's okay. I'm going to be doing a tutorial in English, so, but if you want to follow along, it's linked from the Abierto.cc blog, and it's called Monta tu Fenderino, which I guess Fenderduino used to be what it's called, and now it's Fenderino. Okay, so first it tells us to mount the jack, buttons, and the interrupter. So, let's do that. So our jack is going to go down here. Oh, one sec. There we go. Okay. Down here. And it's got all these crazy little holes that need to be lined up. It doesn't really want to do that right off the bat, so let's take a look. There's 5 very weirdly spaced pins on this jack, which is meaning that I'm going to have to just sort of wiggle it in. Let's see. Go in. Do the thing. Oh, you know what? They might have gotten bent. It's going to be a little bit of a tight fit, but fortunately, you can bend the pins this way and that and get it to fit however you need to. Oh. There we go. Okay, that was a bit of a tight squeeze, but we're all good. On the back of this, incidentally, it has some labeling that says designed in Sweden, which is where David Cuartielles is based right now. He's teaching. And there's a Creative Commons license on there, CC by NC. Let's see, CC stands for Creative Commons, SA is share alike. So, if you make this and adapt it, then you should share it under the same license. By means give attribution for the person who created it, and NC means non-commercial uses. Arbiator.cc and instronics.com. There's lots of different versions of the Creative Commons open source license, so that's a useful thing to have inside your head. Now, this being an exceptionally large PCB, I'm having to use both arms on my little third hand here the whole time. I'm using leaded solder because it's easier for me. However, you do want to make sure that you're in a well-ventilated area and or have a fume extractor to make sure that you're not breathing too much. Lovely smoke there. You can also use lead-free solder, but in my opinion and experience, it doesn't work quite as easily. And so I tend to use this rosin core stuff that's all lead. It just means that you want to wash your hands immediately afterwards, especially before eating anything. Because, yeah, lead is not tasty. I assume. It's metals, right? So, okay, next we've got the buttons. And I think all the button bottoms are the same, but they've got 7 white caps and then 1 black one that goes at the top. So let's see, 1, 2, 3, 4, 5, 6, 7, yes, okay. I'm gonna slot these in from the top. And it's so nice when they sort of hold in there on their own, and you don't really have to bend the leads in any specific way. This is really satisfying right now, just so you know. Two more to go. And I haven't lost anything from this kit yet. That's the real remarkable thing here, is like it's been sitting in the office for a few days, you know, and usually that spells disaster, but yeah, okay, cool. Super snug. That's beautiful. I'm such a dork about this stuff, but it's great, you know? Being a dork is great. Let's get soldering. I'm gonna start at the far end. And as always with soldering, I'm making sure that I am heating both the solder pad and the pin that I'm soldering at the same time, and then applying the solder itself from the other side so that I get this nice spread and even heating across the whole joint. Because you don't want to just heat the pin or just heat the socket. If you do that, then you're liable to get what looks like a bunch of melted solder on there, but then end up with a circuit that isn't actually connected. And the other thing that I'm going for is applying just the right amount of solder so that I get a nice little concave, like a little volcano on there. Which is what means that I have enough solder and it's going to be stable, this little cone, but it also is not going to waste solder. Office is a little noisy today. It's actually coming up on lunchtime with my colleagues, so I'm hoping I can sort of speed solder this. And we're doing pretty okay so far. I actually really enjoy soldering headers, and so those will probably end up being last, I guess. Oh, did I skip a button? I missed a button. Whoops. We'll have to throw that on. I got confused with this because I noticed that at least one tutorial or description said that there were 8 buttons, and then also an extra, like 8 white ones and then 1 black one, when in fact there's 8 in total, including 7 white ones and the black one. There's the final button. Let's solder that on. Can I get away with just one? Yeah, there we go. Okay, check that out. Real pretty. Next, what are we doing? We're doing the interrupter switch. This goes at the bottom here. And since it doesn't really hold itself in there, what I'm going to do is tack solder one of the joints. I'm just going to lay it on the desk here and do one of them. Actually, you know what? I can do them all on the desk, I think. Basically, the deal with that is that you can hold it in a secure place and solder one of the joints, and then move the circuit to a position that's a little bit easier to solder, and that one joint will hold everything else in place. You'll see that when we do the headers later on. Oh, this is such a cute PCB. There we go. Make sure these pins on this switch are pretty thick, so I should really be giving it a nice long time to heat up with the soldering iron before I decide to remove it. Let's just make sure that these are all nice and yeah, okay, cool. Great. Looks solid. There is a little bit of rosin splatter, which is normal. That also means, though, that if you're like really, I'm also soldering way away from my face. This is at like arm's length right now. But if you're soldering close to your face, sometimes you actually do want to wear goggles, because solder splatter is real. Sometimes you're gonna get solder in your face. I've had a couple of near misses in my time as a maker, but you know, just be careful and use your own judgment. So we've done the buttons and the switch. So next is the resistor array and the LED. Okay, this is super cool. There's a little resistor array that goes on here that basically looks like the bridge of the guitar. And so that's going to go in here. I'm not sure if it's got a certain orientation or not. If they're all the same value, then it doesn't matter. But if they have different values, then it does. So I'm going to consult the oracle, i.e. the directions. And the same thing with the LED array. I know that LEDs are polar. They have 2 different sides, so we'll see how it's supposed to go. Okay. Both components are polar, and it's important that you put them in properly the right way, because if you solder them wrong, then it will take you a long time to desolder them from the shield. That's a great point. Since these both have a bunch of pins, that means that it's going to be a huge pain to desolder them, because you'd have to use solder wick or a solder suck or something to remove the solder completely. You can't just melt part of it, because if you melt part of it and try to yank it out, then the other part is going to have re-solidified at the same time. And so this is a great point. You want to make sure you get it right the first time. Okay, so both of them are polar. Check the photograph well, and we'll see that we have oriented the resistor array such that the pin marked with a point in the component. Oh, it's like a chip. It's got a little marker to show you, basically like pin 1 on an IC. if you can see this, on the far left, there's just a little dot there. Cool. I've never worked with a resistor array like this before, so that's cool. So, it has to be mounted on the bottom. Oh, okay, it has to be put in the square. Cool. They actually have really good instructions for this. So basically it has to be put this way. If you can see, there's writing on it on this side, and that's where the little point is. And also that's where this little square mounting hole is. Cool. So now I am going to do a little tack soldering. And just get that in place. Just sort of melting a glob onto there. Oh, I need to clean my iron. It's not a very good joint, but it's enough. Okay. Now let's do the rest of them. And we'll come back to that first one and make it better. Also, my solder is getting all janked up. There we go. Ah, a little too much on there. Got a little glob. There, that's pretty good. How are we looking? Oh yeah, solid. Cool. So now we've got the little resistor array on there, and it's beautiful, and it's lined up with the square hole, and we're happy. Next thing is the LED array. So, oh, they've got even more close-up photos. That's so great. The two following photographs show how the resistor array and the LED should sit, basically. Okay. Now with LEDs, okay, so you can kind of see the internals of them. And I usually don't pay attention to this because I'm usually using either through-hole LEDs, which show you very clearly, like they have two different ways of telling polarity. That's one leg is longer, the positive leg is longer, and also the negative leg has a little flat side sort of, cut into it. Here we don't have either of those luxuries, but we do have the ability to see the different sides of the diode and how they're different. I've never paid attention, like I said, to which side is positive and which side is negative. One of them has the little spot of the LED on it. Now let's see, it says the inverted L shape should sit to the left. So, I'm looking at the shield this way. Can you see that? Yeah. And it looks like this bit, the L-type thing should look to the left. Okay. Yep, that is not the same both ways. And we're going to double check the rest of the photos. Okay, there's only one photo, but it's pretty clear. And I trust that this is mounted correctly. So, we've basically, if you can see, got this with that sticky out bit on the left. The bigger piece is on the left. The smaller piece is on the right. And from this side as well. Then it's going to be the opposite, right? See that? Hopefully this helps for future generations. Okay, now we're going to solder it. And we better be quick with the rest of this because I'm getting pretty hungry. But I'm also really excited. So, it's these two parts of me that always work against each other. Where did it's right there. Ah, it sticks in so well, it looks like it's already soldered. Cool. I should probably have started from the other side. I don't know if you know this. You probably almost certainly don't. But I have a Spanish degree. And I did not expect it to come in this handy for doing electronics. I did not study electronics or computer science or anything. And that may be totally obvious to you, but to me it just indicates that you shouldn't define yourself by your major or by your job or anything else that you're doing temporarily, because there's so much to be interested in, right? So next. Yeah, so as they mentioned, the polarity of the little piezo speaker is not very important. Most speakers are this way. You can sort of hook them up either way and they'll sound pretty much the same. So, if you want to do it the way that they suggest, though, put the positive pin towards the left when you're looking at it this way. So that means I'm going to throw the positive pin over to the left here. And once again, it's a little bit of a tight fit, which once again kind of helps us. And here's like a sort of lazy soldering method that I use when I don't have enough hands. Third hand notwithstanding, it can be useful to be able to hold something in place, as long as you're not holding it in such a way that your other hand is going to get like toasted, right? So I'm going to put a little solder on here. There we go. Make good thermal contact, and then just sort of move the circuit into the solder. And that works pretty well. Great! Potentiometers! We get 2 of them. Oh. So there's 2 different types of kits. Some of them have the same 2 of the same potentiometer, and some of them have 2 different ones. I happen to have a kit with 2 of the same potentiometer, so it doesn't really matter which one I put where. So these are both 5 kiloohms. So it says the difference shouldn't affect you if you use the guitar with headphones or with an amplifier with its own volume control. However, for cheap amplifiers that don't have volume control, it's possible that the guitars with the 5k ohm potentiometer will always sound like they have the same volume. Interesting. Cool. So if you have the one with 100 kiloohms, that one goes on the left, and then the other one goes on the right. But otherwise, we're just gonna put them both down and see what happens. There we go. And there we go. I love how much this looks like an actual guitar. Like, they really made an effort to make this stylish as well as functional. I love it. Totally missing lunch right now. Let's get that stable. Cool. And these potentiometers sit right where they're supposed to. You would think this guy has some experience. I'm really enjoying this build, and I hope that you are too. It's just like aesthetically pleasing, and you know, I'm gonna jinx myself here, but all the little solder joints are going pretty well so far. And The office is not too noisy, so hopefully the sound quality on this video is going to even be pretty nice. It's a Tuesday morning, afternoon. The sun is shining in San Francisco. It's pretty boss. Now, I haven't shorted any of these, have I? Nope. Looks good. Oh, this one looks like it could use a little bit of extra solder. Big holes to fill. No jokes. Good thing I have a huge roll of solder. Okay. So, and Arduino pins. Excellent. So the way that they recommend doing this is that you put the headers into the Arduino as is, and then solder on top of that. So, yeah, cool. The long part goes into the Arduino. I sometimes don't like doing this because sometimes when you're pushing these in, one of the pins will not want to go in the socket and it will like push itself out the other direction. But if that happens, you can just use some kind of a surface to push it back in and it'll be fine. That also is more likely to happen if you've already been soldering on it and the plastic is a little bit warmer and weaker. Yeah. Ooh, what? This one is not quite long enough. I guess, well, these two are the same size. So, I wonder, where is... Okay, so in the picture they have it centered over here. With the last couple of pins just not connected. SD and SCL. I guess we don't need data and clock for this particular thing. Okay, cool. So note that this is where the two unattached pins are, and that's SD and SCL. So now we're going to place the Fenderino on top of that. And the cables go out here, that makes sense. Cool. Oh, beautiful! Oh, this is so nice. I'm going to see if I can zoom in a little bit for you guys. Oh, look at that. Enhance. There we go. Cool. And this is just going to be soldering. It's pretty obvious what's going on. And at this point, all that I have left on my workbench are the keycaps for the buttons and the potentiometers. So I'm pretty excited to be nearing the end here. Exciting and lovely as it has been. Let's see if I can mess anything up in the last like 5 minutes here. That would be exciting. You know what? I'm going to do these ones because there's all these components in the middle. Doesn't make sense to be soldering the left ones yet. Ooh, let's try and be a little careful with this one. So I have a pretty big tip on this soldering iron, which means that I'm getting some like blemishes on the little pick guard here. I mean, obviously it's not a pick guard, it's silk screening, but yeah, so be sure to use a fine tip if you want to keep your Fenderino shiny and pretty. Oh yeah, look at that, a little bit of scorching. But oh well. Those all look pretty good. My solder is getting wrapped around itself. Starting from the left. There we go. And I am using a pretty long piece of solder in my hand, which helps shield my fingers and also gives me a pretty good amount of control. The unfortunate thing is that I'm not going to be able to get this up and running and making noise right now because I don't have that AVR programmer in the office. But to be honest, I have to move on to other things. Not just lunch, but other stuff too. But that just means that you get another installment of this later on. So let's stick these things on and we'll have a look at how it all comes together. And then, yeah, stay tuned for the next iteration, I guess. So first we're going to put on all these keycaps. If you've ever built a keyboard, these are very satisfying. If you've ever built a keyboard, you know that this is one of the best parts of the assembly, right? Oh, come on, there we go. There's all kinds of cool DIY keyboard things on Hackster and beyond. So if you haven't explored it yet, I recommend it. I am supporting this with my fingers to make sure that I don't, because the Arduino is on the bottom here, I don't want to accidentally, it's probably not going to just snap off because it's fiberglass inside the PCB, right? But nonetheless, I don't want to cause unnecessary damage. There's obviously 4 little sort of side things on here and it just snaps on. Cool, that's very satisfying. That's extremely satisfying. Okay, now I'm going to throw these on. So we've got, in the potentiometer housings caps, there's a flat side, corresponds to the flat side on the potentiometer. It's not hard. They take a little bit of elbow grease to put on. Good thing I do pull-ups every day. And yeah, there we go. Cool. Fenderino. I'm gonna zoom out again so we can take an actual. Oh yeah, check that out. Final shot. Gorgeous Fenderino. We're gonna have a go at actually playing this soon. In the meantime, hack on, and we'll see you soon with some more awesome assembly videos. Thank you again, David, for sending this to us. I'm looking forward to further hacks. Alright, have an excellent Tuesday, everybody.